Hi, I'm Mike. Welcome back to my garage. I'm here with my friend Greg, and we're gonna do a little aluminum melting experiment. Greg, why don't you tell us a little about it?
All right, so Mike and I are, hobbyist aluminum casters, and that means we do a lot of scrounging. We get our metal from all over the place. We cut up hard drives and machine parts, and in this instance, we're talking about wire that we have. Now, this came from our local anodizing vendor, and we took in some of our parts that we made before to get anodized, and she said, "Oh, that's kind of cool. Here, why don't you come and check out? This is wire that they use to fixture parts when they dunk them in the chemical tanks to anodize parts." And she said, "Hey, I just take this to the scrap yard and they give me a few pennies for it. Why don't you take a bunch of it?" And I said, "All right." So we have a bunch of it now. And I thought this would be a good opportunity to test out one of the scrounger's dilemmas, which is anodized material good for casting? And yeah, there's not really much information out there about how that works, any issues you might expect, or whether you should even bother at all. So we thought we'd do a little experiment here, because this is what an individual piece of that wire looks like. And you see they've bent it up and twisted it to fixture whatever part they're doing. And then they dunk it in the tank. And so right here is where it's anodized from here down, and up here is the exact same stuff but not anodized. So we went through and we cut up a bunch of that, cut the anodized from the unanodized parts. This bin here is 3 pounds of anodized wire, all crushed up into little pellets for charging our crucible. Some black, some gold like that, some clear coat, kind of hard to see on the camera there. But then also over in the furnace right now, we have 3.0 pounds of the unanodized free ends. And when we do that, we're going to pour up some ingots of both. We're going to treat the same amount of metal the same way, pour up some ingots, weigh out the slag and dross, and see what our yield is like.
All right.
Does that sound good?
Sounds good.
All right, so this is after our first pour. This was our batch of the unanodized ends from this wire that we were cutting up. You can see we got the furnace back on. Now we're melting up the anodized part. We got, I would say, a pretty good yield of ingots. We filled our little corn tray there, one little hemispherical ingot off to the side, and what I would say was very little slag. I was pretty impressed with that. This is 1100 series. She called it dead soft aluminum. I think it's very pure aluminum, not a lot of alloying elements. So when that cools a little bit, we'll weigh those up and tell you exactly how much metal we got out of 3 pounds of wire.
All right, we're about halfway through our experiment. We've already finished pouring out the non-anodized aluminum. And Greg, do you have an update for us?
Yeah, so we did that. We cleverly had the camera pointed somewhere else while we were doing it, so we only got to record the aftermath. But the leftovers cooled pretty quickly, and I wanted to just look at that really quick. I mistakenly called it slag earlier. I looked up the difference. Slag is when it's liquid, dross when it's solid like this. So you can see there's not very much from that batch of good clean aluminum. What did we say, 0.088 pounds?
Yeah.
So just an ounce or two. And that also includes, like, you see this, show it to the camera there, it's shiny. There's some kind of cruddy looking stuff set in some shinier stuff. There was some liquid metal left in the bottom of the crucible. And I poured out what I could, and then I had Mike go ahead and scrape with the spoon on the bottom there, because we were going to turn around and use that same crucible to continue our experiment. So of that 0.088 pounds, some of that is probably usable metal, but that's the methodology that we use to get to that number. I would be pretty happy with that yield if I was doing it. I mean, that's not very much at all.
Yeah, out of 3 pounds.
Yeah, to lose less than 0.1 pounds, I would say is pretty good. But we'll quantify that a little bit more when we weigh up our ingots and when we see what we get from the anodized batch as well.
Okay. Oh, wow.
Oh, my.
There's a lot left in there.
Yes. All right, we'll scrape it out.
Are we not going to... Huh?
No, we can't. That's dross.
So what is this?
That's dross. Scrape it.
Really?
Yeah. That's solid. That can't be poured.
Oh, wow. Look at all that.
Here. Try and pour a bit more of this.
And this is the anodized stuff?
Yeah. Okay, so looking now at the aftermath of our second pour. This was the pour of the anodized stuff. We can see right off the bat our yield's going to be a little bit lower. I could feel as I was stirring it with our spoon and I was stirring in the flux that there was some kind of chunky, so it feels kind of like Jello in the in the crucible. And sometimes you feel that, sometimes you don't. But that's what that is in the pie pan. We scrape that out. We'll weigh that up when it cools down a little bit. But looking at the ingots, we can see, we have one less corn than we did of the other one. Those are usually about 0.4 pounds a piece. So we'll see that when we weigh it. But at first glance, it looks like the anodized stuff has quite a bit more waste. And there was a lot of goo left in the crucible that kind of hindered the pouring. We actually had to scrape some of it out and then go back to pouring again. So here we see the results of our experiment, where we melted anodized and unanodized wire, fixturing wire of soft aluminum, and we wanted to see what our yield would look like. When we looked first, we started by melting the unanodized parts. So this is just raw, clean aluminum, I guess they would call it. And we found, as you can see here, some dross. Some dross, but not a ton. And we think we also caught some what would have been usable metal up in that dross. You can see some of it's shiny. Some of it is a little more, that's the oxide there, the dull stuff. But this reflected our process. This is how we normally melt and how we cast. So, losing a little bit of metal to that is normal. That's to be expected. So over here on the other side, the anodized stuff, you can see there's a whole lot more of that dull oxide, aluminum oxide, which is to be expected. That is how dross works. That's what dross is made of. And that's also what anodizing is made of. So aluminum, when it just sits there, gets called a passivation layer of oxide, just a couple nanometers thick on the surface of, it's forming on these ingots as we speak. And then that's what you kind of get collecting and floating to the top as dross. Anodizing does that on purpose. It makes that layer thicker to make it more wear resistant, corrosion resistant. So it's not surprising to see that we get more waste, more dross from an anodized source. So we weighed these up, we weighed the dross, and Mike, I think you have the numbers in front of you there.
Yes. Okay, so the dross from the non-anodized pile is 0.088 pounds.
So less than a tenth of a pound,
Yeah.
about an ounce.
And the anodized, we got 0.33 pounds.
Okay, so that is about 0.3 pounds more, which passes the eye test because these corn-shaped ingots, we use a corn muffin cast iron tin. Those are usually about 0.4 pounds, and we have one fewer from the anodized, so that makes sense. I'm just going to weigh up here. This is the yield from the clean stuff. Putting it on the scale here. We haven't done this yet, so this is exciting live yield count. Even the little bits that we splashed. 2.914 pounds.
We started out with 3 pounds, correct?
Yeah, 3.008 pounds of,
Yeah.
of material.
Okay.
To get to what did I say, 2.91 pounds, I would say that is a pretty high yield process for backyard casting purposes. Put that back down, and then I'll weigh up the other stuff. And then I got one more comparison I want to make too. Let's put these are still a little bit warm out of the furnace. I don't think that affects the mass of them too much, right?
I hope not.
Stacking those up. These are the little bits and splashes we had, but we will be melting them, so they count as yield. Come on.
And we stamped these so we know which one's which. We can't get them mixed up.
Yeah, we
here,
felt
so.
pretty clever thinking of stamping them. 2.64.
2.64. And that's with our 3.3 or 0.33 pounds. Get close
That, yeah, that's pretty much.
to. Was there any left in the crucible on that one, or did we?
We scraped that out pretty thoroughly, or
Okay.
you scraped it out, and it looked pretty good. Did a pretty good job of scraping it out, and we can pretty much account for all that weight.
Yeah.
Right, 0.33 plus 2.64. We lost 0.01 pounds somewhere in the process. Hard to say where. So let me turn that off. Put this stuff back. There's one more comparison I want to make. Maybe we flip over to the other camera so I can show it more.
You want to take a look at that dross again?
I want to take a look at the back sides of some of these ingots.
Okay. All right.
All right, so I'm going to prop that up there, show the camera. This is the anodized stuff because it's got a lot of the dross there. You notice the back side is pretty lumpy. And when you compare that to how nice and clean and shiny these clean aluminum ingots are, that is, I don't want to say concerning, but it's interesting. And so at some point in the future, I would like to cut these open, just put them on the chop saw and see if I can see any difference in the grain structure there. Because the dross that we scraped out of the crucible after we did all the pouring had kind of this lumpy texture to it. It kind of feels like Jell-O when you're scraping it with the spoon. And the fact that that texture and that surface finish kind of look the same to me makes me wonder if there's dross included in this pour. I don't know how we'll tell, but I'd like to cut one open and see. So that's about all I had to say about those ingots. Is it conclusion time?
Sure.
All right. So the conclusion that I draw from this is that you can get good metal out of anodized parts, anodized scrap metal, whatever you have that you're able to scrounge up and melt. Like I said, we scrounge, so we take what we can get. We've melted anodized stuff before and used it to pour, projects, ashtrays, whatever. But at least in this head-to-head comparison, you're going to get a lot more waste, which is what we expected because there's just more oxide there. It's probably worth noting that when you look at the wire we're using, it's really skinny. It's a high surface area to volume ratio, so we're probably getting a higher dross ratio, a higher oxide ratio than you would just from like a bulk machine part or a hard drive body or whatever else you're using. So you might not get this much loss comparison, but you probably get a little bit. So, any other thoughts?
No, it does have me wondering about some of the other stuff that we have melted down. Maybe we should go compare the backside, because we do have some other corn ingots, and see how they compare between these two tests to see,
So shiny.
to see how much actually have these lumps like this, or if they all actually look like this, because we do melt down anodized parts. So
Yeah, we've pretty much done that since the beginning. Like the extrusions, Parker IPS or 8020, that's all hard coat anodized.
Yeah.
Which is even thicker than the standard. I don't know whether this was hard coat or just stock plain anodizing on this. The wire that we did, it was just whatever she had in her garbage bin. So she was willing to share with us. But yeah, I'd say this is a pretty good demonstration of the benefits and drawbacks of melting anodized aluminum.
All right. Well, thanks guys for watching. Hope to see you again here sometime soon.